Good morning, we bid to our honorable judges. We are doing this solar still in the topic of chemistry. We are from SMK Bukit Jambu. Our team is called the A team. Now we can start explaining our project. After finish assembling most of our model, we will be covering the copper tubing with a thick layer of fine granule. After covering the copper tubing in fine granular, we can now measure the temperature of the granular. The result is around 67.6 Celsius.
Next, we will also be putting the fine granular inside the containment A, which is a black tin. The results will be a black tin filled with fine granular. The use of the fine granular is formed by several types of metal as a solar thermal collector. The fine granular consists of iron and aluminium as a thermal insulation and collector. Aluminium, which is the second highest in thermal conductivity but the highest specific heat capacity, allows the thermal heat to distribute more evenly. Iron, which has a lower specific heat capacity but its density compensation, its deficiency making it the best thermal storage agent.
Now, we'll be moving on to the microcontroller and sensor. We'll be installing the microcontroller and sensor next to the copper tubes. Now, we can put 500 ml of water into the small tin to start the process. In containment B, we will be putting salt on ice that is submerged in water to decrease the temperature of ice. Then, we can measure the container that contains the ice to check the temperature. And the result we got is negative 25.8 Celsius.
Next, we will be opening the vacuum pump. Lower pressure means there's less force pushing down on the water molecules. This makes it easier for them to break free from the liquid surface and enter the air as vapor. This is the evaporation process under low pressure. When the pressure is high, the air can hold more moisture. This means that the water vapor is more likely to condense back into liquid form.
Based on the microcontroller, we can see that the temperature of the copper tubing is high, which means we can now start allowing the water through the tubes.
After a long process, we collected some distilled water in the glass bottle. Now is the time to retrieve the water. First, we can close the valves and take the vacuum pump. After that, we can take out the pipes to retrieve the water. After cleaning the top of the bottle, we can now pour out the water into a small measuring cylinder. This is to measure the volume of water that is collected by our project.
And now for the final test, we are going to test the pH and the ppm of the water. The pH of the water is 7, which makes it neutral. ppm stands for electricity conductivity level, which is 16.
Good morning, judges. Today we are going to explain about our solar steel project in the topic of chemistry. This project was made by our team, the A team, from SMK Bukit Jambu. First and foremost, I'm going to run you through the use of low pressure in our project. The use of low pressure in our project is divided into two sections: evaporation under low pressure and condensation under low pressure. Low pressure means that there's less force pushing down on the water molecules. This makes it easier for them to break free from the liquid surface and enter air as vapor. For the condensation under low pressure, the air can hold less moisture, meaning the water vapor is more likely to condense back into liquid form. Next, I'm going to be showing how low pressure is actually used in our project. For evaporation under low pressure, the water in the bottle evaporates due to fine granular packed in a tin can painted in black, also labeled as contaminant A. For condensation under low pressure, the other bottle that is placed in a container containing ice added with salt is to condensate the water vapor back into liquid form, also labeled as contaminant B. Here comes the next question. Why did we use copper tubing? We decided to use copper tubing as the carrier due to its high thermal conductivity and cover it up with a layer of fine granular, which is a mixture of iron and aluminium, as thermal insulation and collector. Our design focused on better thermal collector, carrier and transfer by also using conductive methods instead of just convection and radiance. And now comes the most important and yet the final part of our project, the secret of ice and salt. When salt reacts with water, it dissolves to become a saltwater solution that contains sodium ions and chloride ions. Now, here's a video of ice and salt which will help us understand the theory.
是 pointed ice 吗？
Okay, put more ice.
等一下，拍多一次，
I got put more.
拍，你还拍这个。
As you can see now, the salt is added into the ice. After salt is added into the ice, it gives us a reading of about negative 25 degrees Celsius to negative 38 degrees Celsius. Last but not least, I'm going to be giving a deep explanation about the use of fine granular in our project. Iron and aluminium is used as a thermal insulation and heat collector. Aluminium being the second highest in thermal conductivity and the highest specific heat capacity. Although iron has a lower specific heat capacity, is the highest for density composition.
That is all from us. Thank you.